I've been reading this paper, Semantic Instance Segmentation for Autonomous Driving, and I would like to discuss it and talk about what I've learned so far in this video. So I'll just go through my notes. And so the first term, when I was reading it, I tried understanding was the metric learning objective. So what that is basically you give a computer a bunch of cats and dogs video, and computer tries to understand the difference between those pictures, images. Sorry, not videos. And so that's basically metric learning objective term, what it refers to. So this is like teaching a computer to measure the difference between the pictures in a way that makes it easier to see which one's a cat and which one's a dog. Then the next term which we have is permutation invariant. So in the context of machine learning, it refers to a model or a function that gives the same output regardless of the order of the input features. So the order of the images that you provide in doesn't actually matter, so you get the same output. Now, why that is relevant? Because if you give a let's say if you give a video stream, then the order of the images do matter, right? Um, so permutation invariant will be used where the order of the images don't matter, or the classification. So it's used in a classification or graph analysis. I don't know what the graph analysis exactly is, but image classification pretty much makes sense. Occlusion. So what is occlusion? Occlusion is when two objects overlap each other. So if you have like cars stacked on the side of each other, so like this image here, or let's say people are walking, crossing the street, and you're looking right at them from 90-degree angle, then that's basically you may see people as like one and a half or one person, but where there is someone there. So that's occlusion. And delta V. In computer vision, delta V can be used to help with tasks like tracking objects in a video or estimating the motion of object in a scene. It's like when you're watching a movie and the camera follows the character as they move. That's a form of object tracking. By calculating the delta V of objects in a video, computers can better understand how things are moving and make a prediction about where they will go next. So you have the speed and the direction, and then you predict where that object will be based on that speed and direction. So delta V is really important concept in both space and computer vision. It helps to understand how things move and blah blah. So I did get the space example first when I asked Grok AI. So I've been asking all these questions to Grok, and I don't know. I just been using Grok now, and I find it a little bit efficient than ChatGPT, which for a short amount of time. It's only been maybe like 3 weeks that I've been using. So one of the like it just has a little bit, it feels a little bit optimized than ChatGPT when you ask for answers. But again, only 3 weeks of uses. So I'll talk about more on that. And so the space example was basically if you're in a 3D space, you want to understand where you need to go, and you also want to understand like how much you propose to get there. So that was the example that was given. Before that, then I asked for a computer vision example, which is much more easy to relate to. Semantic instance segmentation is a computer vision technique that combines the semantic segmentation and instance segmentation. So in semantic segmentation, the goal is to classify each pixel in an image into a specific class. So for example, car, pedestrian, etc. Instance segmentation takes this a step further by identifying individual instances of each class. So if we look at this example here, so what a semantic segmentation do is basically tell us all these pixels, including this pretty much all the pixels around the body of the car, including the when I say the body of the car, like the entire car, and it will tell us that okay, all of these pixels are car. But now, if we combine that information and look at it, is it a long car? Because cars are not that long. So, instance segmentation helps us. Then it tells us, okay, this is one instance, like we can see on this photo here, and it gives us like on information on each instance, so we know, okay, this is not a long car. It's just many cars are parked together, right? Parked alongside. So not alongside, park behind each other. So that's basically what the semantic segmentation and instance segmentation gives us. It gives us that insight from the image, uh, and this is particularly important in autonomous driving, where it is crucial to differentiate between multiple car or pedestrians in a scene. And yes, that is very true. Um, so that's basically what I've learned so far from this paper. And reading, like I probably read this paper like more than 15 times. And when I say I've read it, like I'm not just reading it top to bottom, I'm reading it, and any term, like we just saw that note, any term that I don't understand, I pick them. I either ask Grok, Google, trying to understand, because I don't have much. I have zero experience in computer vision, so that's why I'm trying to research and understand. And the reason I'm reading all this, which I probably should have said in the first part of the video, is I'm going to use this YOLO P. You only look once for panoptic driving perception. I'm going to use this. There's a PyTorch module for this to do lane detection, but what I've read is it not only gives you it not only tells you where the lane lines are in a given image, or like if you give a video stream, it can also tell you where the drivable area within those lane lines as well. And this is another paper that I'm trying to read, and once I have some understanding, I'll create another video. Is So it takes those instant segmentation understanding we just learned about, and tries to use end-to-end learning on that. And what they talk about here is solving basically many lane lines, or lane lines with faded or missing marking, and all these type of things. So, which is a very challenging task. And in this paper, when I read through a couple of times, that's what they they've solved. And like when I say solved, I don't know how much of it solved, but this is apparently it's on based on some benchmarking, which we can cover on the next video. Um, it's one of the, like, it performs pretty well basically, right? So my plan is to use this and build some sort of lane detecting model, and just play around with that, and just try to learn this task of detecting lane lines, and eventually follow those lane lines and try to drive a car on that lane line. So yeah, thank you for watching. Hopefully that gave you some sort of um, understanding, or like that sort of poked curiosity in you. Thank you for watching the video.